In the earlier class, we have discussed about how do you test for restriction in the Var model. In this class, I will basically continue with this problem and see some different approaches of estimating the restriction of the model and how do you test for that restriction, and we will give some example to test how in reality this test for restriction is carried out. Then I will go for Ghose causality testing. I will basically describe how do we mean by Ghose causality testing, and then discuss the practical approaches of estimating such Ghose causality and also give some economic example, that is some example from economic model to handle the problem of Ghose causality. In the earlier class, we had discussed the procedure of testing the hypothesis of 12 lag against the lag of 8. Now, at this point, we could also seek to determine whether the 4 lags will be appropriate. Now, in this context, I must mention that one should take sufficient care in paring down the lag length in this fashion. This is because this procedure will not often reject the null hypothesis of 8 versus 12 lags, although it will reject the null hypothesis of 4 versus 12 lags. Now, the problem with paring down the model is that you may lose small amount of explanatory power at each stage. Overall, total loss in explanatory power can be significant. So, if we find this is to be true, then in such circumstances it is better to use larger lags. So, what we have to do? We have to give some value judgment seeing the value of the test statistics. Now, let us take another example. Now, here I will consider the example of seasonal dummy. Now, suppose you want to estimate the seasonal effect of any variable, say price, quantity, etc. By incorporating the 3 seasonal dummies in each of the n equation of the var. So, in this case, suppose we want to see whether say agricultural production of a commodity has any seasonal effect or not. That is, we want to test whether the behavior of the output vary across different seasons, and since you have 4 seasons, so what we have to incorporate 3 seasonal dummy to make the model be consistent. Now, our first approach will be to estimate the unrestricted model by excluding dummy. Total number of restriction in the system is 3n. Now, if the lag length is p, the equation of the unrestricted model have np plus 4 parameters, that is np lag variable, the intercept term and the 3 seasonal. If for some specified significance level, this calculated value of chi-square exceeds the critical value, the restriction of the no seasonal effect can be rejected. So, this is usual likelihood ratio test. Now, take the example of Ghose causality. This is developed by Ghose in a well-known paper investigating causal relationship between economic models and prospectal methods. Now, consider 2 random variable xt and yt. Now, consider 2 forecast error of xt s period ahead. So, in the first forecast error, we have forecasted the value of xt given the values of past xt's, and in the second forecast we forecast the future values of xt taking into account the past as well as past values of xt as well as past values of yt. Now, in both these two cases, consider the mean square error. Now, if you find that mean square error for the first model is exactly equal to the mean square error for the second model, then our conclusion is that yt does not Granzer cause xt for all s greater than 0. That basically implies yt is not linearly informative to forecast xt. This is because if the value of the two forecast error are identical, then it basically implies it is immaterial whether we actually include or exclude yt. In that case, we basically say that yt do not add any information to the forecasting value of xt, and hence we claim that yt does not Granzer cause xt. Now, to make the point more clear, let us consider our Var example, and let us consider the two examples that we have already using. In a two equation model with p lag, yt does not Granzer cause xt if and only if all the coefficient of lag value of yt in xt equation is 0. So, if all the coefficient of lag value of yt in xt equation is 0, then we are basically claiming that past values of yt are not causing the future values of xt. That is, the past values of yt are not affecting the current value of xt, that is yt is not Granzer causing xt. If yt does not improve the forecasting performance of xt, then yt does not Granzer cause xt. If all the variables in Var are stationary, the direct way to test Granzer causality is to use a standard F test. So, as in our earlier case, assume a lag length of p. So, xt depends on past values of xt up to lag p as well as past values of yt up to lag p. Now, estimate OLS equation and test for the following hypothesis: beta 1, beta 2 up to beta p equal to 0, that is all the coefficient of yt, lag value of yt in the original equation is 0. Against the alternative hypothesis, any beta 1 is not equal to 0. So, here also you use the same kind of testing, obtain the unrestricted sum of square residual RSS1 and also obtain the restricted sum of square error, get the F value, that is the difference between the unrestricted sum of square error minus the restricted sum of square error, and if F follows a chi-square p, then we claim that the restriction is not binding. Now, the test for Granzer causality is different from the concept of exogeneity. Now, for xt to be exogenous, we would require that it must not be affected by contemporaneous value of yt. So, basic idea behind exogeneity is that if xt is said to be exogenous, then the current value of xt is not affecting the current value of yt. So, if xt is exogenous, then there is no contemporaneous correlation between yt and xt. However, Granzer causality refers only to the effect of the past value of yt on the current value of xt. So, in case of Granzer causality, what we are doing? We are trying to find out whether the past values of yt has any effect on the current value of xt. So, Granzer causality actually measures whether current and past value of yt helps to forecast future value of xt. Now, if we forecast xt plus 1 conditional on the value of xt, we obtain forecast error. Now, given the value of xt, information concerning yt does not aid in reducing the forecast error of xt plus 1. So, if yt Granzer cause xt, then incorporating yt will not affect the forecast error of xt plus 1. That is why we say that yt does not Granzer cause xt. Now, in this case, it will be helpful to explain the block exogenity test. Now, block exogenity test is very useful for detecting whether the whether to incorporate additional variable in the Var model. So, if we want to incorporate additional variable into the Var model, we have to perform block exogenity test. Given the aforementioned distinction between causality and exogenity, multivariate generalization of Granzer causality test should actually be called block exogenity test. To determine whether lag of one variable, say Wt, Granzer cause any other variable in the system, we basically perform block exogenity test. So, let me describe the trace procedure. So, let us consider the example of a 3 variable case Wt, Yt and Xt. The test is whether lags of Wt Granzer cause either Yt or Xt. In essence, the block exogenity restricts all the lags of Wt in Yt and Xt to be 0. So, if we find the all lags of Wt either in Yt or in Xt is 0, then we treat W to be exogenous. The cross equation restriction is properly incorporated while carrying out the likelihood ratio test. So, here let us proceed as follows: estimate Yt, Xt and Wt using lag values of Yt, Xt and Wt and estimate the variance covariance matrix of residual. Now, in the next stage, re-estimate the model excluding the lag values of Wt and recalculate the variance covariance matrix of residual. Next, to find out the likelihood test statistics, let us in the next step then calculate likelihood ratio statistics, and these likelihood ratio test statistics should follow a chi-square distribution with 2 p's of degrees of freedom, because p being the number of lag length, the number of restriction in each equation is p and total number of restriction in the system turns out to be twice p. Now, let us consider some example of Granzer causality. Now, in this case, it is useful to carry out the discussion of the Friedman and Kunter paper of 1992, and they consider they consider an economic example where fluctuation in money supply helps to predict the fluctuation in income that is not already predicted on the basis of income itself or any other observable variable. So, what they have found, they tried to find out whether fluctuation in money helps to predict the fluctuation of future income, which is not accounted by income or in past values of income or any other observable variable. Now, in their model, logarithm change in national income depends on its past values, and the past values of the logarithm changes in money supply and the federal government expenditure. This issue is simple. In the present of past values of the changes in income and federal government expenditure, does knowledge of supply series, money supply series provide any information about the future value of income? That is what they have do. They incorporated the impact of the Federal Reserve changes in Federal Reserve and changes in income, and also the changes in money supply series, and they want to see whether the inclusion of money supply changes provide additional information about the forecast values or future values of the national income. They have used several measures of money supply, that is the money base M1, M2 and various short run interest rate, and estimated a 3 variable VAR model. And data they have taken the quarterly data, the 1960 second quarter to 1979 second quarter, and they have tried out different alternative of the model, and the F statistics for the null hypothesis that money does not cause any changes in income is 3.68 at 1% level of significance. So, from the data on F statistics, it is possible to conclude that money supply actually grandeur cause changes in income. So, Friedman and others have found out that there are the effect of some changes in money supply on the future changes in GNP, and they have in fact shown that changes in money supply actually grandeur cause the changes in income. In this class, I have discussed how to carry out the test for restriction in the VAR model. I have given different examples of doing such test procedure. I have discussed what do you mean by grandeur causality, how do you test for such causality, and I have discussed what is the difference between the concept of grandeur causality with that of exogenity. I have discussed what do you mean by block exogenity test and how to carry out the test procedure, and actually I have also given some example for testing out for test of this restriction.